Ignite Talks are 20-slide presentations where each speaker gets only 15 seconds per slide. They have no control over the slides. So all the speakers get just 5 minutes. It's perfect for an evening event where you have beer and you're just having a good time. We're going to have 2 sets. The second set starts at 8:15. The first set starts about now. Now, if you've never been to an Ignite before, we have them all over the world currently. We just had one in DC last week. And if you enjoy what you see tonight, feel free to start your own. You can learn more about Ignite here, or you can watch the Ignite show. But now, without further ado, I'd like to welcome up our first Launchpad contestant. And this is Andrew Weinreich, the CEO of Xtify out of New York, and he's going to be showing you an easy way to location enable your website.
Thank you. Extify is about providing real-time location information about your users to any web application, any website, any web service. Why do I say website and not a thick downloadable client? In large part, it's because we believe the future of mobile is not thick downloadable pieces of software where web developers need to fundamentally rewrite their website, rewrite their web application to know where users are. The holy grail is I should be able to know where my users are on a persistent basis, server side, in real time. And if I can do that, you can deliver services that you couldn't otherwise deliver with a thick downloadable piece of software. What do I mean by that? If I knew where my users were all the time, then I could deliver mobile promotions when they were near a point of interest, when they were near a Starbucks or a hotel or a venue. If I knew where users were in real time, then real estate services. When you go to Douglas Elliman and you say you're looking for a one-bedroom, you would have the ability to deliver a mobile promotion, literally as someone's walking down the block to say, that apartment you're looking for is right near you. How do we do that? We freely distribute a snippet of code. It's live on a BlackBerry, Android, Windows, and Symbian platform. And this snippet of code extracts location in real time, either GPS, cell ID, or MAC address, and publishes it up to the Xtify platform, the Xtify cloud, if you will. And Xtify then exposes that location through a REST API to web developers. We offer APIs of many flavors. One, the simplest one is the pull API, where you can literally, without any contact with us, write to our API and grab location. So what would that look like? If you were a real estate service, you could literally say, when someone comes to the New York Times or Douglas Elliman, how would you like to share your location so we can store your query and then push location information, relevant information to you as appropriate. So the distribution is predicated on the development partners. Let me give you a few quick examples of what that looks like. A few integration points. So you've all seen Google Latitude, the idea that Google can share with you, not just where you are, but where your friends are. But that shouldn't be just the domain of Google. Anyone with Xtify can build the equivalent of Google Latitude. Anybody can build a social network on top of Xtify. Why is that? Because we have the ability to extend to social networks this freely distributed piece of software that can grab users' locations. So if you look here, see my where, it's a Xtify implementation. I can type in my name because in this implementation, I'm sharing my location. But other users could simply share their location, and you can even imagine a buddy list here. Here's something called My Every Move. It's another implementation. It's a geo diary. So you may not be interested in everyone knowing where you are, but how cool would it be if you knew 40 years from now everywhere you were to the 15-minute increment? And that's quite literally what's happening here. I am from New York. I landed, I can literally watch as I'm driving down. I could literally go into my diary and watch as I was driving down 101. Here I am on April 1st in Las Vegas, and I can track the rest of my behavior. Here's a mobile dating application that has the ability to know where users are so they can rank relevant matches based upon their proximity. But even more importantly than that, as a user is walking around, the dating service has the ability to push profiles that are relevant to that user. So the service is called Xtify. You can see the pull API at xtify.com. We also are introducing push APIs where you can put your business logic into the cloud. And the documentation is available for anyone to see at xtify.com, as are the APIs. And we're happy to help anyone as they look to integrate location into their application without the need to build an iPhone app or a BlackBerry app, but quite literally to know where their users are with their existing services, whether it be a web application or a WAP interface or SMS or email. Thank you.
Thank you very much, Andrew. And now, if you were reading TechCrunch last night, you probably read about Glympse. And Bryan Trussel, the CEO of Glympse, is here to describe what it's like, or the reason you would share your location for just a short period of time. Please welcome up Bryan.
Thank you. I'm very excited to be here tonight. I'm pretty tired. As Brady said, we just launched today our public beta on the G1 phone, but my excitement is overwhelming my tiredness right now. We're super excited with the reception we've had from the press and from our consumers so far. We launched on the G1 phone today, and I'm going to show you the demo. I'm going to just jump into it so you can kind of see the product that we have here. So we built Glympse with this idea that the way people want to share their location is things that they already do every day during their normal schedule. You go to work, you have coworkers that you're exchanging location with. We usually do this by a phone call or by text messaging. I'm on my way. Here I am, where are you? Meet me when I get there. You go to lunch with somebody, friends, maybe you make a call on a business client. You head home at night. Have you left yet? Are you on your way home? Are you stuck in traffic? Or on the weekends or in the evenings, you go out with your friends, and it's always, where are you? I'll meet you there. You guys left the restaurant yet? Or are you at the bar? So it integrates into our daily lives. So that's what we wanted to create. If I can get the Elmo on. That's what we wanted to create with Glympse. So I'm going to show you. What you do is you download the app to your smartphone. Like I said, we launched on the G1. I'm going to show you the demo here on the iPhone. You'll see your location on a map, and then you just hit send. And what you do is then you're going to select who you want to share your location with. So you just go to the to, and you can pick a person out of your address book, their phone number, or their email, and you type that in, and then you just hit the send button, and that's it, right? So any mobile phone number you want, any email address you want, just type it in, enter it, hit send, and it's off. And now you're sharing location with that person. Now the key to what we do is our Glympse watch technology, patent pending, with this duration element. So you decide exactly how long you want to share your location with another person, be it just where I am right now, be it where I'm going to be for the next 30 minutes, 1 hour, 4 hours, whatever. So let's just pick one. Let's just say an hour, and that'll fill in, and then you hit send. What that does is for a text message, it'll send off a link, and the recipient, with no special software, will just click on that. It'll open up a mobile browser and show a visual map where you are, and they can refresh that in real time during that duration of that glimpse to see where you are. Let me show you what it looks like on the website. If you send a Glympse to somebody in email, they would just get an email that said, hey, Bryan wants to share his location with you. See if I get that centered. Well, I won't be able to zoom in here, but you can zoom in, you can zoom out, and you get this real time. I'll pan just so you can see it, of that person and where they're at on the map. Here we go. So you can change into a satellite mode if you want. Let me zoom out a little farther. Maybe if we're bringing down the tiles there. Let me see if I'll go to street. You can change into traveling mode and have that person just going due north and follow them along wherever they're at as they move along. And this is real time. It takes the GPS or the triangulation. We use our friends at Skyhook, great partners, to zoom in on this location and then share it up to the recipient. Now, I didn't show you on the UI here on the Elmo, but you can also, when you send a glimpse, if you want to, you can send a message to say, hey, I'm running late, or I'm leaving now, or meet me when I get there. And you can also put a destination. And if you put on a destination, that'll also show up on this map, along with the message over here. And it'll have an ETA. So if you're going to go meet somebody, if you're going to make a business lunch, if you're making a delivery, whatever it is, it'll have that ETA. So the person in real time has a rich, interactive experience to give them that information. You send a glimpse once before you leave, and there's no more of this, hey, I'm on my way, I'm stuck in traffic, I'm still late, I'm looking for a parking spot. So it's a very efficient, easy way to share your location with folks. I want to emphasize on the receiving end, nobody has any special software. They just click a link, and it's just a web page and a little bit of flash. Let's see if the satellite stuff will come up now. I'm feeling lucky. So one of the things that when I showed you how this works on the Elmo, when you send a glimpse, it is just a couple seconds. But the thing I didn't show you is all the stuff that's missing. We don't make you create another social network. You don't have to go up and create a username and an account and then tell your friends, hey, do you have the same phone I do? Go download some of this software and go sign up for an account and go sign up with your own username and password. And let's make this social location. You don't have to do all that work ahead of time of I'll invite you and then you invite me and then we'll be sharing our location together. With Glympse, you don't have to build another social network. People don't want to live in another social network. It's not how we live our lives with the location. It ebbs and flows and moves back and forth with people that might be close to us, might be colleagues, might be somebody we've never even met. I can make a business call to somebody, send them a glimpse before I meet them. They'll see exactly where I am, and when we're done, it's over with. So we're very excited. I want to say thanks to Ware for letting us talk tonight. I want to say thanks to Steve Miller, my partner, who did an amazing amount of work to bring this to fruition, and to all the folks up in Seattle on the team that worked so hard to make this happen. Thank you very much.
And one of the great joys of having been at all 5 Ware 2.0s, and this is the 5th one, is seeing Web 2.0 mapping techniques start to creak into larger organizations. And here from NASA is Sam Hiatt to talk about just that.
Thank you very much. My name is Sam Hiatt. I'm with the Ecological Forecasting Lab at NASA Ames Research Center. I'm part of a co-op with NASA and CSU Monterey Bay. We're doing a lot of interesting things with geospatial data. Particularly, we're trying to address a lot of problems and attempts to save the planet. It's a pretty big problem to try and save. I'm wondering when my slide's gonna. There it is. We're trying to save the planet. One of the ways we can do this is by using satellite imagery that's constantly monitoring the Earth to monitor how the ecosystem is responding to things like climate change. As many of you know, NASA has a network of satellites constantly monitoring the Earth, sometimes on up to a daily time step. Now, one of the interesting things about satellite data that we tend to forget is that it doesn't only use and track visible light, but it also looks at other parts of the electromagnetic spectrum, allowing us to monitor things like vegetation condition. You see here a map of vegetation condition in the US, and since the satellites are constantly constantly scanning the Earth, it produces a time series archive of data that we can then go back and look at to see how, for example, vegetation is changing through time, to try and track long-term trends or anomalies or disturbances in a certain area. Now, just monitoring the satellite imagery, we're not really able to look into the future. But if we combine satellite data with ecosystem models that use climate and weather data and weather forecasts, we're able to look at how many different processes are affected in the ecosystem. We use numerical ecosystem models that describe interactions between water, carbon, and nutrition. In the past 10 years, our lab has been developing the terrestrial observation and prediction system, which seamlessly integrates satellite data and weather and climate forecasts, and uses ecosystem models to give us products that are very useful in a variety of different applications. We're actually working on a project with the National Park Service to try and extend the use of our data to them. The inventory and monitoring program of the NPS has the goal of monitoring park ecosystems and monitoring ecosystem dynamics. But we're struggling with the problem of how to get them all this data. There's tons of data. How do we get it to them? Do we put it on an FTP site and just say, here you go, have at it, have fun with it? That doesn't really work. We're working with a lot of people with different backgrounds, and so we wanted to provide them a web-based client, a web application that they are able to that serves our data, that allows them to get current to get estimates of current conditions on the landscape. You see here a map of vegetation condition. And this is the screenshot of the application that we built for the National Park Service. They're able to see many different layers. You see here a layer that shows an anomaly in the vegetation index. The user is actually able to query this point and generate a time series graph to see how the vegetation responded to this. In this case, it was a forest fire, and you can see on the at the end of that plot the effect of that forest fire. And our hope is that by getting this data into the hands of park resource managers, that we're making a big step to try and to let people react to our data and make use of it. We're also working to improve our anomaly detection algorithms. We're also working on many projects to develop decision support systems to address things like water resource management or carbon monitoring. We're very excited about the partnership we have with Cisco called the Planetary Skin. We're going to be providing data to them to monitor carbon stocks and fluxes. We have a lot of different collaborators and customers, and we're very excited to see where geospatial technology and the web will take us in the future. Thank you very much.
Thanks, Sam. And where it's one of the places it's going to take us next is all the way back around to full-scale GIS analysis tools. And here to talk about using web tools for crime analysis is David Felcan.
Hi, I'm here to talk about HunchLab. HunchLab is a new way to look at points in time as they change. We use HunchLab for crime, and it's basically a density change detector system. Typically, crime is discussed in this CompStat, which is a once-a-month meeting that police have. But this is slow. The idea is to create an iterative process, something that's interactive and more interesting. Typically, crime is looked at as a pin map, where we have time and events happening. But this is very hard to extract information from. It's just a lot of data just kind of slapped there in your face, and you're just trying to figure out, well, what's going on. We're rolling out HunchLab in Philadelphia, and with all these points, it's just a big blob. You really can't make a lot of sense out of stuff with a pin map like this. It also doesn't publicize very well. So you have a data tornado coming at you. And the idea behind HunchLab is to use the computer to figure out actionable information from this huge mass of points and use that to do something with it. Typically, we use this heat map, where the red is where there's a lot of crime and yellow where there's not much. However, that's not really good for crime because crime tends to happen in the same places. So bad neighborhoods stay bad. What we really want to look at is how it's changing over time. And in this case, we have 1 week here, the next week, and it's hard to tell where the densities are changing. I can't tell just by looking at it. So the idea is to produce a statistical algorithm which will tell us. Basically, the idea is we take an area or a set of areas, and we're going to call these crimes here balls in a bag. And some of the balls are black, and some of the balls are white. And we're going to take a big tranche and just grab it out and look at the distribution of the balls. There's going to be black balls and white balls. And using this algorithm, we can tell if this is an anomalous spread. And here's the graph. Okay, so you got time running along your z-axis, and you've got x and y, and you basically have your spatial area running as a big cylinder running down the middle. And then this can feed. This goes to feed this algorithm, which is n, g, n, and x. You feed it into the algorithm, which is a black box, and then out comes a p-value lattice, which tells you where in this spatial area you've got particular anomalous occurrences going on. And so HunchLab allows you to take this algorithm, but it puts a skin around it so that anyone can use it. And also you can share your results, and it can really help make this easy for everyone to use and share. So typically in HunchLab, you might get something like this. It's a notification coming from the system. It says, oh, look, there's something going on weird here. This is a strange anomaly here. So then you get a link, and you can click on that, and that brings you into the HunchLab system to do some more analysis. And this is kind of what it looks like. You've got your circle there, which shows the area in question, and a graph of all the incidents that have occurred over the past year. And you've also got a history of the p-values that the system has determined for this area in the last few days. When you click on the graph, it gives you a count of how many, and you can see here why the system picked this out. This is an exceptional number of crimes for this area. But when you click on the bar, it not only does it give you a count, but it also then drills you down into the actual spatial information that you're interested in. And we're back here at the pin map. However, the pin map is in a context. Suddenly, we're looking for specific information about these crimes in this place, which has already been designated as anomalous. So the user can then go and create their own hunches and figure out, yeah, hey, I want to look at this area that's nearby where this hunch is. I want to look at that area. I want to draw a polygon that looks like this. Or I want this particular area. So the user can create their own. You can also, in a shotgun manner, blanket an area with these hunches and just sort of let the statistics kind of figure it out for you where there's something weird going on. And it's just as easy as creating a single hunch. You fill out a form, designate the area, and boom, you're done. Then you can search the hunches that are in the system. You can say, hey, in the TA22 area, Bob is looking at this at hunches here too. So this is really exciting. I'm going to send an email to him. Or you can look based on class and so forth. What's really exciting is this algorithm is not just limited to crime. It's anything in events in space and time. We can look at home sales, we can look at pollution, we can look at cars, anything. And the system is general enough it can do all that. Thanks.
Products like Universal 9 and the next product, Social Explorer, are examples of GIS analysis really coming online. And here to show another example of that is Ahmed. Please welcome him.
Thank you. My name is Ahmed Lazavik. I'm a developer at Social Explorer. I'm going to do a quick demo of our website. This is a Social Explorer website. We have two main sections, the map section and the report section. Oh, Social Explorer is a demographic research website. So we have census data from 1790 to the present. I'm going to just click on the map right there. This is ACS data, which is the American Community Survey. This is the county map. I'm going to switch this to Census 2000 tract map. The second drop-down is a category. We can choose, let's say, for example, income. I'm going to zoom into San Francisco. The more you zoom in, the more detail starts to show up. We're looking at census tract data right now. Something that there's a lot of data. We have about 15,000 variables across time. So something that's actually currently relevant would be same-sex unmarried partner households in San Francisco. This is something that's relevant currently. So now I'm just going to do a quick report of this area and pull up the data behind it. I'm going to choose the points method. I'm going to do a spatial search where I put the point and click on Make Report. The report comes up with the data. We provide the aggregate on the right side. We give you the context, the United States, the state, the county, and your selection, and then your selection aggregated. At the bottom of the report, there's a map that shows your selected area. Now, the mapping interface is definitely very attractive, but we've spent a lot of time actually processing the data, and it's the data that drive this whole thing. And we've provided the visual interface to the data. We have the reports. We have a data download section, which you can use to download the data in CSV format and bring it into other packages like GIS or your stat package like SAS or SPSS or Stata. And we would like to add a third interface, which would be an API so that other websites can interface with our data and pull demographic information. We have something like over 200,000 variables across time, and one of the main challenges actually that we had to deal with is the geographic boundaries are changing over time from 1790 to the present, especially the census tracts, which are the neighborhood boundary level data. So we've basically created a system that can normalize the data on the fly, and also we've created a metadata system to allow us to track which variables are actually comparable over time. I don't have that much time to show you all the over time features, but I do want to show you one more map, which is the carbon dioxide emissions map. We also have this is carbon dioxide emissions map from the Falcon project, and we also have the religion data at the county level. If there's anybody out there who is interested in being a consumer for our API, I'd like to talk to you. And the help section, you can watch the videos that explain how to use the website, and everything is illustrated here as well. Thank you very much.
Thank you very much, Ahmed. Now, I would say that space hacking and data are back where geo-hacking and data were back before Where 2.0, before the Google Maps API. There's a lot of data out there, there's a lot of interest, but it's locked up in silos. And it's just now starting to leak out, and Ariel's been tracking these space hacks, and she's here to share those with us. Please welcome Ariel.
Oh, hi. So I'm Ariel Waldman. I'm the creator of spacehack.org. Spacehack.org is essentially a directory of ways to participate in space exploration. A lot of what space hacking has to do with is actually contributing to the space program, not just sending your name up into a spaceship or something like that. So what's going on right now is there's a lot of collaboration happening. NASA is opening up a lot of their data. They're using platforms like Django and Python, so people are able to collaborate in much faster ways. And so a lot of this is making the space program work at a faster rate. So like the Tron guy that wants Tron right now, we want the space program right now, and we want it fast. So don't be a hipster and be complaining about where your jetpack is or various other things. Say, you know what, I want to go to the moon, and I'm a little bit too lazy to be in a rocket. I want a fucking space elevator, and I want it by 2010. And actually, that's what one of the projects is doing. Elevator 2010 is actively trying to get those answers by next year. There's also projects like Galaxy Zoo, which are allowing people to actively find new galaxies. And so you can see the green peas galaxies at the top. Those are being found by regular people like you and me. Why this is important is because people can do things robots can't. Robots are actually kind of dumb. They can't identify galaxies, but people can. And in fact, in Galaxy Zoo, over 200,000 people are identifying 250,000 of these galaxies. There's also projects like Stardust at Home, which sent aerogel up into a comet and collected all these different particles of dust. Excuse me, I'm having trouble breathing like in space. Forgive me. But so there's 1.6 million dust bunnies that essentially need analyzing, and people can do this a lot better. And scientists, it would take them the better half of their lives. So people can actively help scientists get us there faster. There's also projects like L-Cross, which is taking an SUV-sized payload and slamming it into the moon, quite literally, at 5,600 miles per hour, creating a crater on the moon to look for water crystals. Why it's important to find water crystals is because from this crater there will be a plume of regolith, and if we do find water crystals on the moon, it will make it easier for us to actually live on the moon, have an actual outpost on the moon, which is a lot cooler than what we've been doing currently. So why this is important to the public is because NASA, while they talk a big talk and try and be really awesome, they actually need our help. They need amateur astronomers to help them give data about these types of things to help us live on the moon. There's also projects like Institute for the Future did a program with CubeSats trying to forecast what it would be like if everyone had a CubeSat similar to an iPod. Well, some people thought this would revolutionize sort of citizen science and be a really great effect. Other people thought it would lead to orbital debris and have satellites colliding into each other. And if you've been paying attention to the recent news in the last few months, this is actually happening and it's a real problem. So while not everyone is at the point where you can have a CubeSat like an iPod, there are projects like SEDSat2, which allows students to be able to actively join teams and build their own CubeSats. So we're not there yet where it's like an iPod, but we're getting pretty close. There's also programs like Google Lunar X Prize, which have various teams trying to build robots to send to the moon to collect different types of data. And this is really cool, but not everyone is a robotics person. So there's open source teams like Team FredNet, which are open source. They allow different types of people to try and help solve this problem. If that fails and you're feeling really lazy, there's things like Study at Home, which allow you to use your extra computing power to look for extraterrestrials while you're, I don't know, doing something other than being on the internet. I don't know what that would be, honestly. Sorry, aliens. So there's other things like astrometry.net where you can upload pictures to Flickr, where astrometry.net will tag your photos with where in the sky you took these. And not only does it help your Flickr photos, but it also helps add to their database. If all else fails, there's co-working opportunities. Space people are in this room right now. You can talk to them, I promise. But there's also things like Bar Camp NASA that are being organized in Houston. Open Luna Foundation, which is trying to send people to the moon for open source ways. All the other ways that you can participate in space exploration are on spacehack.org. And I thank you very much.
Good job. Thank you very much, Ariel. That was great. Now, we have 3 more talks. They're all about open. 2 are software, 1 is about data. And the first one is from Chippy on a map rectifier.
Hi. Yeah, I'm Chippy, or Tim, as I'm otherwise known. I was here a couple of years ago talking about geocoder. I'm here to talk about MapWarper.net. which is a way to geo-rectify, geo-reference, and warp and stretch your maps to put them on the internet. And so this is a slide showing a map and an image. And one is referenced on top of the map, and the other one is kind of warped. This was taken as someone flew into Canning Town, flew into London. So by now you're probably thinking, this isn't new. We've seen this before. Yahoo Map Mixer is dead. Microsoft Map Cruncher, Windows only. And other desktop things, a bit expensive. So I wanted something that's free, open source, initially to be used with OpenStreetMap, and something whereby people who love maps and want to use maps can put them on the internet. Some of the images and some of the maps we have include one in the Philippines, that's the top left, which is a shiny, metal-y thing that someone's taken a photo of. Michael, there we go, and one on the lamb banana. It was very good. But most of them are maps, and old maps, out of copyright maps, and a certain amount of aerial imagery that's taken by astronauts. So sign on and you upload your map, and it then adds itself to a repository. You can then browse and you can search other people's maps and images. This is the main page. This is the main where all the action happens, where you basically add one dot here, one dot there, add them together. You can get an error report as well for each point to give you some indication of how accurate you are. And the output, you've probably seen this before in a desktop environment, that you can get. So it's nicely warped. This is one of Morocco in northern Africa. You can also crop an area, so to get rid of those outlines. And cropping comes in useful when you're making a layer or a mosaic of other maps that other people have uploaded or you have yourself and you've rectified that. So that's a layer. This is different from the other ones. So some of the export options involve KML for use in Google Maps and Google Earth, WMS, so by standard for that. You can also download the geo-rectified GeoTIFF, which is all very good. It's crowdsourced, so the idea is that other people can play with your maps and make them better, more accurate, better fit. You can put all your maps up there and get other people to do that. So I want to make this better and faster and stronger. I'm looking for a nicer server. What would you like for that to happen? I'd like to search by year, so to search over time, and by area as well, search by map. That'd be useful. Okay, this is the obligatory lolcat and OpenStreetMap slide. It was basically, you have a WMS, you put it in there, you can trace over the top. So I took a photo there of the map. Another application would be obviously to work with map libraries. People have a vast repository of maps available. And that's one of Brooklyn. That's very nice. That's by the New York Public Library. And we're actually working with the New York Public Library to digitize thousands and thousands of their maps. And there's a nice image of, in Brooklyn again, I think, of some slides there. But all's not fun and games. You can't really use proprietary data to rectify against because of the bad thing called derivative works. So we have to use open data. And it's actually led to an anti-pattern in the UK, and a lot of councils in the UK have vast. They have old maps, but they've used Ordnance Survey data to rectify against, so we can't actually use that. So I say, let's free our old maps. We can get it ourselves. We can rectify it against good information. Let's go beyond that and let's make it an open historical project of all old maps over time. So if you're interested in that, let's meet up afterwards. And what else would you like to see on that? Have a look, but do take it easy because it'll probably break. Okay, thank you.
Thank you very much, Chippy. And that concludes our program for the evening. You don't have to go home, but you can't stay here. Personally, I'm probably going to head downstairs and get a drink. I hope you join me. Let's give a hand to all the speakers.